I'll begin with a brief corporate overview of Kellton Tech. We're a global company, a pioneer of digital transformation with a footprint in lots of different areas, the USA, UK, Ireland, Singapore, India, to name a few. We were founded in 2009, and our clients range from startups to Fortune 500 companies. Our core strengths are people and technology. We've got a lot of accreditations on ISO and CNNI, and we're a public-owned company with a team of over 1,500 globally. We are particularly strong in terms of numbers in the US, in India, and we have a small startup team in Europe at the moment, and we're growing year on year by organic growth and acquisition. So I'll introduce you to our panelists today. Siva is Senior Architect at Kelton Tech Solutions. Sean, Global Director for Manufacturing with Software AG. And I'm going to hand over to Siva to take you through the Kelton Tech side of things now.
Thank you, Paul. Are you able to see my screen?
Not yet, no.
Okay, just give me a minute.
Yeah.
How about now?
Nope.
I'm sorry, let me.
Yeah.
Okay, Siva, I can see your screen.
Okay, great. Thank you, Ram.
I'm not sure if all the participants, it's started to publish as well or not. But yeah, good.
Okay, great. So thanks everyone for joining today. This is Siva Chowli, Senior Architect, predominantly working in the integrations, APIs, and IoT space. Today, our topic of interest is how can we make IoT deliver the business value? Lately, we see that a lot of the companies across the industry are very ambitious about the results that they can get the IoT implementations, but they don't see that value yet. So that's the topic of our interest today. So in appreciation for your time, we value your time. So we promise to deliver some valuable content, and we organized our content delivery in this way. I'll be talking, we have our partner Software AG joining us in this webinar today. So just like the previous series of webinars, we will also be doing this in partnership. So I from Kelton Tech will be talking about the IoT introduction, pilot statistics, and some revenue growth opportunities while giving industry examples and what are various IoT implementation pitfalls that the companies are going through. And we'll talk about some architectural considerations and successful implementation strategy. I'll also be focusing on build versus buy of the IoT platforms. And I'm sure this would be of your interest because we have also come up with some functional and technical scoring for the top 4 IoT platforms available in the industry, including Software AG's Cumulosity. We will then be handing it over to Software AG to talk about IoT challenges and Cumulosity and manufacturing specific industry use cases. And then I'll be delivering about Kelton Tech expertise and value proposition, our center of excellence, and our recent case study implementation using Cumulosity. With that context, without any more delay, I would have a deep dive into the topic today. IoT, Internet of Things. I'm sure in this stage of the digital era, we don't need a special or any more introduction to IoT. It just talks about connecting the physical world with the digital world to drive the efficiencies in revenue. And how do we do that? The physical things around us as simple as your toothbrush or a shoe or a weighing machine or your car, or from the industrial IoT perspective, talk about the manufacturing equipment or manufacturing plants, or the electrical appliances, whatnot, your smartwatches, are all connected or embedded with the IoT sensors to be able to do some remote actions on them, or collect the physical properties of those devices itself, or collect the physical properties happening around those physical things, and even collecting the behavioral properties of the people or humans who are using those devices. The idea is to generate as much data as possible through this connected physical things and use the data towards some business value. So, like we said, the various examples of IoT include connected car. For example, in the vehicle manufacturing industry, I can think of a number of IoT use cases. For example, you can capture you can have the sensors embedded into cars and connect them with internet and capture the real-time risk analytics of the driver for the insurance industry. And you can also have a real-time alerting mechanism to the rescue systems like the police department or hospitals for crashes and again in the client's perspective as well. It can also do a predictive maintenance alerts generated and then share it with the nearby dealers or your company dealers, so that they can come and proactively and approach with the current deals in their offering. And in the healthcare industry, patient monitoring and whatnot, smart cities, there are n number of use cases that the industries are going behind this IoT concept these days. So, in brief, IoT in action across the industries and regions. So we see that 60% of the manufacturing companies are realizing the value of IoT, and they started implementing IoT at some level of maturity, whereas the rest of the industries are a little bit lagging behind. And when it comes to the region-wise statistics, we see that North America is heading with IoT implementations with almost 45% of the companies going towards IoT. And India is in the next place, and APAC is in the last place. So apparently, manufacturing in USA and EMEA or manufacturing companies in EMEA and North America are really going towards this IoT oriented business models. So while our focus is on manufacturing industry today, we will be also talking about IoT in general, and we'll cover the rest of the industry specific examples as well as the talk goes. So coming to specifically on the IoT implementations, we have captured some statistics from various sources like McKinsey and Capgemini and sources like that. So 70% of the companies which have started to adopt this IoT are failing to capture the real business value out of those pilots. And there are n number of reasons for that, which we'll be discussing in the coming slides. 85% of the companies are spending more than a year of time in their pilots, and 28% of the companies are spending more than 2 years. Essentially, which means that these pilot implementations are going very slow, and yet not delivering the right business value. So, and of course, 60% of the enterprises also are not seeing the right value delivered because they do not have right analytical capabilities. So when we talk about consistently business value, what exactly are we talking about? What is the business value that we are talking about? So here is that list. So when we have the IoT connected world, the success factors are measured essentially in the way how we improve the operational efficiencies of the companies, and how efficiently are we delivering the solutions, and how much time to market has been reduced with the IoT, and what is the differentiator of your product or service with that of your competitors? What value is IoT bringing in terms of that differentiation? And the customer satisfaction. First thing, personalized. When we talk about the human behavioral analytics as well with IoT data, what is the data used towards? It's actually used towards creating personalized business models for those customers. When we do that, of course, the customer satisfaction increases, and the customers would even turn into loyal customers and then be your promoters, and of course help towards expansion of the business. And it also empowers the sales and marketing professionals to be able to use this IoT generated data and then upsell or cross-sell products. For example, in the utilities industry, I can think of a direct use case. If I can connect my electrical appliances to IoT connected sensors, then I can probably understand how much power is consumed by a refrigerator of a customer. And then if it has not an efficient or power efficient device, appliance, then I can recommend him. I can connect him to my marketing team on the energy efficiency program, and then connect him to my digital marketplace and be able to sell or be able to establish a communication channel about an opportunity to sell a new energy efficient appliance. And it's also about enabling new business models. New business models, to that extent, we can talk about exploring the hidden business territories. Meaning, so you collect the data, you have tie-ups with other companies too. So you always talk about this IoT will help you talk about the selling, upselling or cross-selling the complementary products as well. So it actually generates some new business revenue streams when you talk about being able to sell the complementary products as well. And in the specific manufacturing industry, it talks about assets management, like the manufacturing equipment management. For example, a small disruption in the manufacturing plant could lead to delayed completion of those manufacturing processes, and so a predictive maintenance about the manufacturing plants wear and tear could be helpful to take an action beforehand and be able to have a continuity in the manufacturing process, thus reducing any delays and of course achieve the operational efficiency. So thus it reduces the time to market, and of course it also reduces the cost to maintain and for the materials as well. What are various common IoT implementation pitfalls that we usually see across the implementation in the pilots? So mostly when we talk about IoT is hyped to an extent that people started, or the organization started to embrace this IoT as a technology versus a business driver. So focusing on technology over strategy and or solving a business goal, so that leads them to get into that IoT hype, and then miss the actual point about what business problem they're solving. They don't know where to start, so they don't know what exactly are they solving, or sometimes they might know what problem they're solving, but they lack in big picture. So that IoT consulting is something that comes into picture here. So probably when we think of IoT implementations, how do we start about it? How do we even draft our business use cases, and how do we create a business expansion plan using this IoT business model itself is something that has to be thoroughly thought about. And the next one is like a decision of building the IoT platform or building the IoT solution versus buying it, and of course, and ability to customize. So this is one topic I would like to park and then talk in elaboration in the upcoming slides. So the next one is lack of industry governance on standards and security. And one study actually talks about why these IoTs are not able to deliver the business value because of the security issues, the internet security issues. security has been the major concern for a lot of these organizations, and there is no standard governance from the industry. So a lot of organizations do their proprietary implementations and then realize some of the problems during the process, and then try to patch those problems with other custom solutions. They essentially go into loops and try to solve those problems, but that actually delays the time to market. So, and of course, IoT standards and protocols, IoT solutioning itself is very huge, and I would say it's an ocean. So when I first started to implement this IoT concepts or understand this IoT concepts and implementations, it was like a huge concept to talk about, because you have n number of protocols to talk about, n number of ways to analyze this data and even integrate with cloud. So there are a lot more things to really concerned about. So I'll be talking a little bit about all of this in my architectural consultation slide. So unawareness around this big picture of the IoT implementations is also something which leads the organizations to fall into that trap of doing the things in a technology-oriented approach. So the next one is unable to leverage the data collected, of course. So you have the some companies that even some of our customers as well, their approach is to start with improving the operational efficiencies and reduce the time to market. So they start with connecting the devices to the actual product itself, and they solve the problem. And through that, they have also an opportunity to capture the auditing data and the device data, and they do store it in the cloud systems. But what next? So that data usable for them in any other way? So are they analyzing the data to think of the newer business models, or analyzing the patterns of the data and then think about some creative ways of or innovative ways of generating some new business models? Probably not. So that actually is not happening because they do not have the right analytical capabilities, which might include the technology competence itself, or it can be the tools itself, or it can be the business model itself. The business model may not have the real vision about this level of implementation in their roadmap. So coming to the IoT successful implementation strategies. So I always believe the biggest business value is delivered through the IoT when the IoT generated data is leveraged at its fullest potential. So various stages of implementation for that to leverage the data at its fullest potential is to first think about connecting the devices. Once the devices are connected, so the first stage is to have the device operational maintenance of those devices, being able to capture the data from those devices and being able to perform some remote operations on those devices, collect the data. And the next step is to integrate that data and then store it into the cloud systems. So data storage and integration with the rest of the enterprise applications would come into the picture at this point. And the next step is to analyze the data. Analyze the data includes a lot. This means a lot. So predictive analysis, so that using the data generated, you would be able to do the predictive analytics of that data and then see the wear and tear of the manufacturing equipment, if that's the use case, or any other use case. Use your machine learning algorithms to generate this predictive analytics and take actions beforehand. And in fact, identify any anomalies in this process. Next step is to integrate. This data with the rest of the enterprise and B2B system. The next and final step is to innovate. Innovate means create newer business models. So most of the times we see that the companies do stop at or think of the first level implementation, which is just operational efficiencies and automating the stuff. That's where they do stop. But the bigger roadmap would also include analyzing the right data with the right predictive analytics and machine learning algorithms, analyzing those behavioral patterns, integrating with the rest of the data, integration, enterprise application systems. And also, final step is to be able to innovate and upsell and cross-sell your products. Let's get into some technology discussion here on the IoT architectural considerations. So when we think of the IoT considerations, the primary thing to look at, as we talked about, it's business over technology rather than technology over business. So let's talk about the business considerations first. Have a detailed approach or detailed view on what are the functional requirements and what would be the business expansion plan, and what kind of business agility are we targeting, and how can my IoT solution can deliver that business agility. When we talk about agility, it's also some people are also concerned about the operational stability of the environment, and so business agility and continuity is also one consideration. So the other one is like pricing models. So when we choose with when we go with some IoT platforms, what kind of pricing models or licensing models do they have? How does it impact your business plans down the line? Is it going to cost you more or reduce your cost down the line? Are there any hidden costs, stuff like that? And multi-tenancy. So a lot of the organizations these days have multi-organization model. So that may be happening because of various mergers and acquisitions happening around, or they may want to maintain organizations on region-based, or or they may want to have each business unit running as their own one single organization. So in all those cases, if you want to really have a multi-tenant environment, or you may want to even create for your customers itself, you may want to create your customer line of business itself. You may want to create a business unit, an organization for each of them. In all those cases, essentially, your parent organization may need a multi-tenant environment. Multi-tenant essentially is talked in the public cloud concepts, where a lot of companies and organizations are keeping their data in the same data storage environment, same region, or in the same data center in that cloud. And it talks about, and each organization in this case is one tenant on that cloud system. So when there's multiple tenants are sharing the same public cloud environment, how do you make sure that your data is safe and secure in the hands of that cloud provider? So how is this handled? And do we have ability to customize your business domains? And how do you rebrand your IoT platform in terms to reflect your own brand versus the IoT platform itself, the technology company itself? These are some business considerations. Coming to the technology considerations of it. So first thing, like we talked about, device management. Device management talks about installation or registering the devices, the IoT platforms, to be able to install them, maintain the device IDs, and identify the devices, and secure the device communications, and support for various variety of devices. Device monitoring and real-time analytics. For example, a device is not available at a specific location, you need to be alerted at that point, something like that. And edge computing versus cloud computing. In which cases do we do the edge analytics, and in which cases should we capture the data into the cloud systems and the analytics there? How do you manage the software and firmware on that devices, etc. would all come under the device management. So once we capture the data, then interoperability. Interoperability actually talks about, so oftentimes we may want to load this data into your enterprise IT systems like legacy systems like mainframe or SAP or databases, etc. Sometimes your IT systems may not have the ability to receive the encrypted data that's coming out of these devices. Or sometimes you may not want to have a point-to-point communication directly from your IoT platforms to your enterprise IT systems. So what kind of integration pattern should we use, and what kind of integration mechanisms and solutions are available for you is something that comes under the data integration concept. So once the data has been integrated with this rest of the enterprise IT systems and stored in the cloud storage, then the next step is to be able to analyze the data. The data analysis is again a huge concept, which essentially talks about visualizing and creating the reports out of the data, and using the machine learning algorithms for finding the anomalies and the patterns, and creating alert mechanisms and proactive corrective actions, and filtering of the data, and correlation of the data, aggregation, pattern recognition, and etc. So we may essentially, these are all, this may all sound like some theoretical concepts which may or may not be applicable at this stage of my IoT implementation. The architects might think this way, but it is essential to think about the big picture of all these things, especially about these analytics, and that will essentially, make the way you implement change the way you implement the solutions. It's essential to think about the big picture of this analytics as well. Performance. So before I go to the performance, I would like to talk a little bit about the device management and device protocols as well, the IoT protocols. So the lightweight machine-to-machine protocols and the data protocols, like the supportability for the data protocols like REST, MQTT, or XMP, etc. And communication protocols like your cellular networks like 4G, LTE, or WAN, or LoRaWAN, ZigBee, etc. So how do we reduce the delays in the communication? How do we optimize the performance? Stuff like that. And scalability and extensibility of the solution. Again, so how do we scale this solution to various other business units, or to across the geographies, or to an extent. So we want to be cautious about the solutioning. So every step we take in terms of this technology architecture, we want to make sure this solution is extensible in the long-term vision. And the deployment models. So edge. So you can have the thin edge or thick edge, meaning you can have the analytics done at the edge computing itself, or edge systems itself, like your IoT bridges. Sometimes your IoT sensors may themselves be communicating directly with your IoT platforms, or sometimes you may want to have an IoT bridge or IoT gateway created, and your IoT sensors would connect to that gateway, and at that gateway level you may want to perform certain analytics. In which cases should we do the edge computing versus in which cases want to do the cloud computing? So loose coupling is another important aspect when we talk about devices. Like we said, it's essential to think about those devices, or choose those devices choose those platforms which has support for a variety of devices, variety of gateways, integration platforms, and analytical platforms. So you may want to be able to replace one system easily if it is not meeting your needs down the line. So loose coupling across all this architecture is essential. So customization support. So sometimes customization is something which I'll be talking a little bit more in detail in the next slides. Security does come at every aspect of the above technology considerations. Security could be in terms of data integrity, or in terms of the device data security, or device security itself, or the communication from device to the IoT platform, or from IoT platform to your cloud data storage systems, and between from your IoT platforms to your enterprise IT systems, and everywhere. So security is really a very crucial and critical component that organizations are really worried about. How do you take care of such security issues? So we really need someone who has specialty expertise in these areas. Is my HTTPS communication sufficient, or should we have the edge analytics also, the edge computing also in the data before sending IoT platforms? And how do I integrate with cloud systems? When I'm talking about the hybrid integration platforms, from the on-premise edge system to the cloud IoT platform or cloud integration platform. How do I exchange the data? What kind of security aspects into from the enterprise firewalls perspective, and a lot more. So at every stage of this IoT framework, security plays a very crucial role. With these aspects, I would like to talk about the Kellton exercise of choosing the right IoT platform. So we did compare the 5 IoT platforms, the top 5 IoT platforms in the market, which is Google Cloud, Microsoft Azure, ThinkWorks, AWS, and Cumulocity. So we have identified features and then indicated the support metrics here. So I'm not going to go in detail, but I'll leave it for you to read it. But we do also want to know, let you know that this exercise we did it in a generic way, but some of these evaluations are subject to the customer specific scenarios. So we will be happy to conduct more customer specific evaluations when if you are in need. So here is a slide that talks about functionality-based scorecard for an IoT platform. So in this, we created the functionality-based score on a scale of 1 to 5, with 5 being highest and 1 being lowest. Azure seems to be getting 53 out of 60 from the core functionality, device communication, availability, and time to market, etc. perspective. And AWS is scoring for 6 out of 60. And Cumulocity, Software Ages Cumulocity, is scoring 59. Again, these are the kind of functionalities that we rated based on our experience with the clients that we have worked. So, and this course might vary from a different customer environment perspective, from a different customer use case perspective. Yeah, build versus buy versus customizable. So when we are choosing the right IoT platform, so often organizations get into this discussion about should we buy a product versus build the product from the scratch. Of course, this discussion is not only for the IoT platforms but across all software products itself. So we have captured some metrics about what are the base factors which influence the build decision versus the buy decision. When it comes to the compliance, so build from the scratch, when you have everything in your hand, so you would have the most compliance adhered solutions. Your time to market is actually high because you are building everything from the scratch. That's where the IoT platforms would come into the picture. So essentially, your time to market and the buy off of the shelf is relatively far lesser, and you may want to put in high maintenance for your solutions that are built from the scratch, and your maintenance from the other side is low, and you have a lot more flexibility in terms of customization for the built solutions, whereas for the off-the-shelf products, you may have restricted customization support. But I would like to focus on one research that McNation did in terms of IoT platforms build versus buy calculator. So there is a link over here that talks about how to come up with the build versus buy for the IoT platform. So here is that slide that talks about it, the URL. So it talks about the type of IoT device, the deployment model, annual inflation rate, platform management capabilities, edge processing capabilities, operate phase labor, design development labor, etc. It considers almost all aspects into consideration, and you just have to fill in those years and then see how much extent the build. How much would be your budget for a build versus buy. So mostly it is observed to be the buy is taking far lesser than the build. So in other words, 40% your deployment and operational costs are lesser in the 40% lesser in the the products that were bought off the shelf versus the build. So with this, I'll hand over that talk to my partner, Sean, today. Sean, over to you.
Thanks, Siva. Appreciate it. Looking forward to a nice conversation, and I enjoyed your presentation as well. So we're going to cover very quickly what are some challenges with IoT, as well as some case studies and ways on how to overcome them. So that being said, sorry, 1 second here. So that being said, we're going to start off with looking at why are IoT projects having difficulty, and what state are they in right now? So we're seeing several ongoing IoT projects, but most of these projects are failing to make it into productions. There are a lot of reasons for this, but long completion times with various groups that are running in silos or resistant to change, with budget overruns, sometimes lack of internal expertise, or other causes, difficulty with integration, or because of the poor quality of the data that's collected. And because of that, we're seeing issues in terms of being able to move out of the experimentation phase and into the actual business phase. In recent studies by McKinsey and Capgemini, they show that about 80% of IoT projects failed to convert to adopted business practices. And that means they really become a one-time exercise that are isolated in a specific area or group, and they don't get fully integrated into the business as usual. So they're not part of the mantra of what somebody does on a day-to-day business. And one large reason for that is it's difficult for a lot of companies to articulate the business value of their IoT POC. And there are also a wide variety of reasons for that, with not having clear objectives set, not really understanding what we want to obtain from this POC, having the POC take too long. For example, running a 3-month, 6-month POC, when in reality, a 30-day experiment is much more valuable and appropriate to directionally tell, well, what could my return on this particular investment be, especially if we decide to scale it out of this experimentation phase. So right now we're seeing, and Siva touched on this before, according to Bain, security is still the remaining leading barrier for adoption. But if you look at the rest of the tail there, IT-OT integration is at the top, as well as that unclear return on investment that we covered. And IT-OT integration is an interesting issue because it spans not just technology issues, but also cultural issues, where you're getting two groups that traditionally haven't necessarily worked with each other in the past, and you're having them discuss how to solve a problem together, and they're used to different vocabularies. They're used to different meanings for the same acronyms, i.e. uptime. What if you ask an operations person what is acceptable uptime, he'll give you a very different answer than a traditional IT person. The other interesting part is, the lack of internal expertise to implement and operate. And that really touches on that IoT works in an ecosystem, and you're going to have an ecosystem of both internal and external partners working on these platforms together. So having a platform that does not satisfy a wide range of users is going to be problematic, and that's again why it's a key obstacle. Being able to move data in and out, whether it's in real time or whether it's large amounts of batches, i.e. I've got my IoT platform, it's got data on it, but I've got a corporate-wide data lake that I want to move that data into. And because I have connected products or connected production equipment that is generating vast amounts of data, moving that data isn't necessarily something that I want to do with, say, a REST API. I want to be able to move it in a very specific manner so that I can perform long-term analysis on it and maybe maintain it for auditing. And then at the far end of the tail, there are two issues that I think are as important as security, and that is the network constraints, i.e., what type of connectivity limitations do I have? If I have a platform that works really well in a cloud, but I want to deploy this to a production facility in an emerging network that has a 56K network connection, it's not going to work very well. As well as how do I make sure that my platform is able to play nice in the sandbox with everyone? And that's a fair concern, especially in the OT world, whereas operations technologies professionals dealt with a lot of proprietary protocols for the equipment that they were purchasing, and that kept them from being able to share that data with other vendors. So how do we overcome those challenges? Well, the first, when you're looking at how do I prove ROI quickly, be able to rapidly create a solution. And we'll get into exactly what rapidly means, but it's all about speed, and more speed in terms of implementing, understanding, and using the platform. So how fast do we think a IoT solution should be? You should be able to connect a device, which includes registering it and being able to manage it in less than 5 minutes. Create a dashboard with analytics that drive real-time condition-based alerts in less than 10 minutes. Integrate your platform to other applications in less than 10 minutes, and then build an IoT application in approximately less than 30 minutes. So you've got an hour to 2 hours worth of work to get your platform up and running, depending on how fast you are at that. But those are specific times that we've seen benchmarked on the Cumulocity IoT platform. So our second challenge is, IoT platforms don't offer the full functionality, and they're difficult to couple with core business functions. And that goes back to that second point from Bain, that IT-OT integration. So some quick tips. Number one, being able to ensure that your platform is agnostic, i.e. it plays well in the sandbox with everyone, as well as it's easy for business users to use as well. And there's always going to be function that IT users, the developers have to support. But you also want to make sure that as business users want to control the analytics, as business users want to connect to different data sources to assist in a process. So for example, if I'm looking at a field service process, I want to be able to take my alerts and construe data that says, hey, perform a check in my CRM to make sure to look at the warranty and entitlements on this piece of equipment, and then be able to automatically open up a ticket in my field service management platform based on the information coming out of the CRM. And that's a absolutely critical piece of functionality to have. Also, when we talk about being able to have multiple different lead-ins for the different personas that are going to be using it, again, starting with the developer, that's where a platform, you can be able to write code. In the Software AG platform, we have an Eclipse-based tooling methodology for a developer to utilize. And that's for both condition alerts, multivariate analysis, as well as being able to implement and execute on predictive models. We also have a technical or business analyst role that allows for slightly more graphical usage, but it also has the ability to go back to the source code view. And then lastly, the full business user, which has drag and drop smart rules, as well as an interesting model builder that allows business users to perform more advanced analytics. So in looking at, sorry, we got a little freeze there. And looking at the third challenge, and we talked about the network connectivity, usage types. The answer to network connectivity or latency, whether it's through the network or whether it's just sending information to a cloud and back, and your production lines are operating at a faster rate, is really ensuring you have a distributed architecture in place, and that you're able to connect your distributed architecture easily and simply. And distributed architecture means really, we want to have analytics running in the cloud. We want to have them on an edge. We want to have the analytics running perhaps in a data center that's central to a production facility, it's central to a region, or it's central to a corporate environment. But in all cases, we want all three of those analytics uses to be the same. We don't want to have different forms or types of analytics, because then that goes back to the platform becomes difficult to use, and your experimentation typically tends to fail, as well as that all powerful ROI number is difficult to obtain. When we're talking about IT-OT integration and being able to overcome that second challenge, there are a couple of keys to have that manageable. And the first, we're talking about availability. And that's where if the production facility needs to operate at 5 nines of availability, your IT-OT platform has to operate at higher than 5 nines of availability. And it has to be extraordinarily highly scalable, simply because there's going to be a lot of data passed through it, depending upon if it's a production facility, again, when production is running, if it's at peak performance, or whether it's down for maintenance, those are going to require two very different sizes of data transfer. Secondly, be able to provide an enormous amount of flexibility and speed with that flexibility, so that you can connect to multiple different systems, multiple different devices and pieces of equipment. And then lastly, be flexible with your deployment options. And it goes back to the distributed architecture, but also a distributed architecture for IT-OT integration, where your integration can be deployed in a plant, it can be deployed regionally, or it can be deployed centrally, but they are all managed centrally, so that you don't have to have an IT person on staff on the ground in a plant that might be on the opposite side of the world. And then, of course, ensure that security of that platform is extraordinarily high, and you're able to support uptime as well with that security. And then lastly, device flexibility, which again is ensure that as you're putting in a platform, it has a large number of devices supported out of the box, as well as a interface that allows for development of any other additions that might not necessarily be there. So lastly, in the maturity curve for value, where we see value occurring is when you're starting with connecting and managing the devices. Typically, there's not a significant amount of value in just connecting devices. The value starts to increase exponentially when you move towards analytics, when you move towards being able to understand the state of my equipment, either through simple rules, multivariate analysis on condition, or dynamic prediction that's using those condition bases. And then the full value is typically realized when you've fully integrated this into your overall process, and you are now executing actions in real time on a automated basis. And an automated basis could be, again, the automatic dispatching of technicians, automatic ordering of components for repair, or the automatic entry of a maintenance request into a CMMS application. So to conclude, we'd just like to share one quick story of one of our customers. Is a great customer, Doer, and they have a paint booth that they manage for many OEMs. And they were receiving approximately 60 different signals every 8 milliseconds on the status of their paint booth. And the concept was, hey, we don't want to catch errors after multiple cars have gone through the booth. We don't want to catch errors that could impact an entire car. We want to intercede with an error when that error is easily solvable in a very small portion by plant personnel without having to rework the entire car. And that's where they realized, hey, you know what? It's really difficult to do this with a cloud-based system simply because of the latency. So they deployed both condition monitoring and predictive scoring to the edge to be able to quickly identify these particular issues, and then be able to intercede with enough time. And while that was very successful, it did raise a challenge. And the challenge was we needed to be able to allow our field technicians to use the system, because they have a lot of knowledge in terms of what's happening in those particular systems, how those systems have been maintained in the past, and how those systems perform. So by giving them a simple graphical user interface to leverage, they're able to input all of their knowledge without the help of IT, and customize the analytics per every machine specific to that piece of equipment's functionality. So thanks for the time, and I'm going to allow Siva to wrap up here.
Sure. Thanks a lot. Thanks a lot, Sean. It was very useful talk. Can we go to the next slide, please? So Kellton Tech Solutions has been in the IoT space for more than 7 years, and we are serving, or we have served almost 10 plus customers so far, with 50 plus IoT experts working across the projects. We have really got that competitive edge in terms of being able to solve the IoT problems of the companies in a strategic way. So there is a link for the IoT Center of Excellence that you can see there, starting from the IoT product vision or strategy, or consulting, devices, hardware design and development, or IoT quality assurance, or even IoT system integrations, etc. We have our own presence there, and we bring our own knowledge, which is definitely differentiable with respect to other implementation vendors across. And our IoT implementation stack is not just limited to Himlosity, AWS, and Azure. We also have IoT presence in the other end, enterprise IoT components like IBM Watson, Device Hive, and SAP's Leonardo IoT as well. So can you go to the next slide, please? So I would like to come up with one case study that we have recently implemented for one of our customers in the US who are into access control and security solutions in the global market. So they are they do provide access and security solutions, the keys, I mean, the locks and doors manufacturing, they do have the competitive edge already over the market, but there are certain gaps that they want to fill, also time to market, and then being able to differentiate and withstand other competition that will come along. And that's where they thought of the IoT solution, and they envisioned this IoT solution could improve their current product and improve their competitive edge. So how Kellton Tech helped? So this is our essential roadmap through with this client. So we were invited for the IoT implementation and feasibility workshop by the customer. Can we go to the next slide, please? Yeah, so we conducted a deep dive on the feasibility workshop where we understood the current processes, we understood the data security and authentication needs, the platform selection. Essentially, this is where we actually had a remarkable decision here, or contributed to the decision of our customer. What kind of IoT platform should we choose? So one of the slides that I walked you through, choosing the right IoT platform, is something which we leveraged for our customer, and we optimized and tailored that evaluation sheet specific to our particular customer's needs. And we came up with high-level solution architecture and use cases in the first place. And then in terms of the strategy planning, so we did create a scenario planning and how it's going to impact the current business strategy, how we are going to integrate the legacy systems. And overall, from the implementation perspective, we laid out the strategy and got the approach from the customers. And then we developed the business case. In this case, we created the transformation impact, the current business model, and its stakeholders. And we also have created the return on investment models, and then got it approved. And in the implementation roadmap, we actually developed and created the development and deployment strategy, and defined the platform to be used. Again, like in this case, it's Cumulosity, and defined the protocols to be used, and created the solution architecture at the low level. Can we go to the next slide? At this stage, we started the pilot project, we developed the POCs, we validated the results. I would like to add one more point. We also have helped our customer is a multi-tenant environment, so we were helping them out with rebranding the IoT platform with their own specific needs, and even for the subtenants as well. So, and then once the pilot project has been approved and proven to meeting all the requirements by the customer, that's when we started to get the feedback, and then consider end-to-end deployment, change management, and went on with the solution scaling. This has been a successful implementation. The customer is already running in production right now, and of course we are still working with them, but we still are engaged with them in terms of the future opportunities for our customers include leveraging this data and then being able to integrate with the rest of the enterprise applications. Can we go to the next slide? Yeah, so with Kellton Tech, with our software AG Center of Excellence, the digital integration practice, we are also experienced and experienced in the integration space and API space. We work on software AG, webmethods.io, API management, and analytics like streaming analytics like Apama, or predictive analytics like Dementis kind of analytics platforms. With this digital transformation capabilities, and not only with software AG but with other vendors as well, we do provide an end-to-end IoT solutioning that meets all the IoT strategies that we talked about in the past. So that's all I have. I think at this point we would leave it for the question and answers.
Okay, guys. So we've had some questions come in there when the talks are going. Thank you very much to Sean and Siva there. Just going to run through them now. So a question from Lembach. When do edge analytics add value? And that's to you, Sean.
Good question. So edge analytics specifically add value when speed of action comes into play, as well as when there are connectivity challenges, i.e. either a network isn't available or a piece of equipment is, let's say, buried in a production facility that you want to monitor, and there's no really good way to connect reliably into your customer's location to obtain data from that equipment in a secure manner. So those are the two key areas when you'll really realize the most amount of value from edge analytics.
Excellent. And final question here from Arnie Nocton, and it's what is the difference in value between condition monitoring, multivariate analysis, and prediction?
So that's also a good question, and I'll give a brief example. Condition monitoring is really, if you have a compressor, you say, you know what, send me an alert when my temperature on my compressor increases by 5%. Multivariate analysis looks at, send me an alert if temperature on the compressor goes up by 5% and RPMs go up by the same percent, and fluid viscosity is at level Y as opposed to level X, and this occurs over a 20-minute time period. And that's really where you're combining multiple condition bases to create a more educated condition alarm. And then of course prediction runs with I've got a compressor, give me the remaining useful life of that compressor in days so that I know when I need to take action.
Okay, fantastic, Sean. Thanks very much. Anybody got any more questions before we wrap for now? Conscious of time. Okay, nothing else coming in. So these are all the questions we have right now. If you do have any additional questions, please feel free to email us by responding to the email address on your webinar invite, and we will respond to you promptly. As I mentioned earlier, we'll be sending out the recorded version of this webinar in the next few days. We are cognizant of GDPR in Europe, so we will only send the correspondence you opted in for. Thank you very much, everybody, for joining us. You've been a very good audience today. If you have any further questions or would like to continue the conversation about trials on IoT in general, please email us at ask@keltontech.com or visit our website at www.keltontech.com. Thanks very much.
Thank you all.